Hello and welcome back to Chem Clips by Mr. B. In today's video, we'll be focusing on tackling a past paper question on empirical formulae. So let's get started. So you've been told a different type of kiln is used to manufacture Portland cement. The main active minerals in Portland cement are called alite and belite. The table below shows the composition of a compound formed in alite that contains only the elements calcium, silicon, and oxygen. Use these percentage by mass data to determine the empirical formulae of the compound. So you've got calcium, silicon, and oxygen. You've been given the percentage by mass of calcium and silicon, but you've not been given it for oxygen. So what is it that we're doing? Well, what is meant by the term empirical formulae? The empirical formula is simply the simplest whole number ratio of atoms of each element in a compound. So we need to work out what the formula is, the simplest whole number ratio of elements in this compound. To do this, we need to start off by working out the percentage by mass of oxygen. Okay, so this is what we're going to do. Whenever you're given percentages, right, regardless of whether it's percentage by mass or otherwise, always assume you've got 100 grams. Always assume you've got 100 grams of the substance, okay? So I'm going to assume that I have got, for calcium, silicon, and oxygen, I've got, for calcium, 52.67 grams. For silicon, I've got 12.30 grams. So if I'm assuming I'm starting off with 100 grams of my substance, then that means that to work out the mass of oxygen is simply going to be 52.67 plus 12.30. Subtract this from 100. So let's do that. So let's do 100. Oops, no, that didn't work. 100 minus, and we've got 52.67 plus 12.30, and that gives us a value of 35.03. So that's 35.03 grams of oxygen. Now that we've worked out what mass of oxygen we have, we can work out the moles using the relationship moles is equal to mass over mR. So the mR of calcium is 40.1. The mR of silicon, I can't recall. Let's have a look at the periodic table. Silicon underneath carbon. Okay, it's got a mR of 28.1. And oxygen simply 16. Let's put these into the calculator and see what we get for the moles. So we've got, in the first case, 52.67 divided by 40.1. Yeah, that gives us 1.31. 1.31 moles. We've got for the next one, 12.30 divided by 28.1. That gives us a value of 0.438. And for the last one, we're going to get 35.03 divided by 16, and we end up with 2.19. 2.19. Problem is, we can't just say, okay, the empirical formula is going to be Ca 1.31, Si 0.438, and O 2.19, because this isn't the empirical formula. This, remember, empirical formula is simplest whole number ratio of atoms. So we need to work out what the simplest whole number ratio of atoms are. How we can do this? Well, we're going to divide the values of these moles by the lowest value of moles that we just calculated, lowest number being that. So I'm going to divide by 0.438. So in the first case, I'm going to do 1.31 divided by the answer, which was 0.438. And I'm going to get, okay, hang on, I've not done that correctly. Let's try that again. 1.31 divided by 0.438 should be 3. What's going on? Oh, goodness me. 1 point. Take care when you're putting the values into the calculator. I'm clearly making loads of errors. So that's going to be a value of 3. 0.438 divided by 0.438. I don't need a calculator for that, thank goodness. That's just 1. 2.19 divided by 0.438 is 5. Yeah, 5. So there we go. Our empirical formulae is going to be calculated as Ca3 Si1. I'm not going to show the 1. You don't need to show it. And it's O5. That's all there is to it. Hope that helped. Until next time. Bye.